Hello everybody, so today I will present you our presentation about mathematical modeling and numerical thermal simulation of selective laser sintering process of the polyamide 12. So my name is Hanania Gobi, PhD student from Mechanical Laboratory from Ensamraba. So in this presentation I will follow this plan. I will start by an introduction and research objective. Then I will talk about problem description and formulation. I will present you our thermal modeling of selective laser sintering process. And I will explain numerical study with the radial basis function mesh frame method and also using definite element by console software. Then we will show the results and discussion, and I will finish by the conclusion. So first of all, the definition of additive manufacturing according to standard AFNOR is a set of processes allowing to manufacture layer by layer by addition of material physical objects from digital objects. So the selective laser sintering process is among the 7 technologies of additive manufacturing. It was developed in 1990 at University Texas in USA, and the materials used are in the polymers and nylon. The materials are in powder form, and the melted powder becomes supporting material. So what is the operation of the selective laser sintering process? So the selective sintering process is a manufacturing technique made with plastic and elastomer powder, which uses the 5-type structural triangle language produced by 3-dimensional modelization software for building the component layer by layer until the part is complete. Using a CO2 laser beam which melts the polyamide powders by tracing the actual cross-section line after line with using scanner system. The powder is fast to solidify, and finished product is allowed to cool for 12 to 24 hours, then it's extracted from the powder. So what is the advantage of the selective laser sintering process? So using this process make us able to produce functional polymer products at full density, which is eco-friendly, and we have high build rate, and we don't need any support structure, and we can produce accurate and durable plastic parts, and we have wide range of materials available with excellent mechanical properties for functional parts application. So this technology is very recognized technology and well established, especially in the industrial sector, such as prototyping and manufacturing of cars, houses, etc. And in the arts fields, entertainment, medical sector, food, etc. So the major problem that affect quality of the final part in selective laser sintering process is the appearance of delimitation and volumetric deformation, such as the curling and lateral growth, as you see in this picture. So the definition of the residual stress is the constraint without external force application. There are 2 types, the compression type and traction type, such as deformation and cracking, and their origins are the thermal gradients. So our thermal model is based about the resolution of heat equation, taking into consideration the conduction, convection, and the radiation. So in the initial condition, we put preheating temperature, and in boundary condition, we have the convection terms and the radiation terms. This is the Gaussian source model is given by the following expression, which Q is the specific thermal power of the laser radiation, P is the power of laser, and R is the spot diameters of laser spot size. So what is the advantage of radial basis function mesh frame method? So the classical methods, as you know, definite element or definite volume method have difficulty dealing with problems in which one observes distortion of mesh, large deformation, and discontinuous or fragmentation of the domain of study. So the non-mesh methods allow to obtain transformation of partial differential equation systems into algebraic equation systems over the whole field of study without using a mesh predefined. So we use set of bound distributed in the field of study where the distribution of known functions is evaluated. And here with computer program writing by MATLAB software and using radial basis function meshless method, the laser selective sintering of the first layer of nylon 12 powders is simulated in the cast of rectangular layer cross-section having the following physical dimension. So the temperature at the surface center of powder bed is calculated perpendicular to the projection of the support. So as the result, we have compared our evolution of the temperature at top surfaces in the powder bed of polyamide 12 by mesh-free method and also with the console software. And we have comparing this to experimental analysis of the part bed during selective laser sintering with figure 12, and figure shows the temperature in the powder bed between 165 Celsius degree and 175 Celsius that showed good agreement with our tuned numerical simulation, which the maximal temperature is 175 Celsius. So in conclusion, the proposed thermal model was validated by other experimental work, and it's necessary to take into consideration the phenomenon of convection and the phenomenon of radiation, and using the radial basis function meshless method, simulation at the surface and the middle and at the bottom also of the first layer of nylon 12 powder of selective laser sintering process was done by the following of the evolution of temperature as function of time, and we have found good results with console software also. And thank you so much.